So hi everyone. So I am Vannel. I am a second-year graduate student at Kennesaw State University, and a returning intern with HPCC Systems. And this year I've been working, as Lauren said, on implementing a preprocessing bundle for HPCC Systems Machine Learning library. So to start, I would like to ask you, so what do you think is the most time-consuming phase of a machine learning project? Okay, so I would expect from Bob answer at the end that most of the guests have said that data preparation is the most time-consuming phase, as we can see from a typical machine learning pipeline, where we usually spend most of our time preparing our data, making sure that the training is done on meaningful data. So what are the current tools provided by HPC Systems for data preparation? Because that's what we worked on during the internship. So currently, you can do data exploration using this amazing bundle provided by HPCC Systems, which is the data patterns module, which has this profile function and also this beautiful view where you can actually get pretty much all the information you want about your data. You could have the number of samples, you could have the distribution of your data. So this is the go-to tool as far as data exploration is concerned. So if you want to do some data cleaning or some data transformation, you obviously again have a bunch of HPCC tools available at hand. But during the internship, we were wondering, so what if you want to do more machine learning specific transformations, like transforming labels into numbers, like performing standard scaling, like normalizing? So you could still do that, but you will have to use a combination of the previously shown functions and modules. So we wanted to make it easier, and the vision is to be able to have an even more complete package than the sklearn library of Python. So that's the vision and the goal of this preprocessing bundle that we work on during the internship. So I will now present each of the modules and functions on the current version of the preprocessing bundle. So currently we have seven modules functions, so those two combined. So the first two, label encoder and hot encoder, so those two are there to allow you to handle data sets containing categorical features. And then the following three are standard scalar, min-max scalar, and normalize. So they are there to allow you to scale your data. And then the last two, split and stratify. Split are there for allowing you to split your data set into training and test set easily. So we'll present each of them individually. So starting with the label encoder, so as I mentioned, it allows you to transform your data labels into numbers. So you can do this easily with the label encoder, and its API is as follows. So its API contains 4 main functions. So the two ones below, so you have an encode function and a decode function. So those two takes as parameter the data you want to process and a key. So the key basically contains the mapping between the numbers and the categories. And to get the key, you definitely need some data from which you will extract those categories. So the get mapping function will allow you to actually visualize which number has been assigned to which category. So on the following slide, you will have the data structure required by the key. So the key is a raw data set of set of strings, and each feature must match the name of the categorical feature in your data set. So you can see this from this example, where you have from line 3 to 6 the definition of a key. So it has a level and a color attribute, which basically means that those two are the categorical features in your data set. And then you will define the key. So in this case, in this example, you could see that the programmer decided to set the categories himself for the level, but for the colors, he basically left it empty and using the GetKey function to extract the remaining categories for the color. So if you want to import some categories, you can write it on your own. But if you want just the categories to be extracted from any data set you have at hand, you can use the GetKey function for that. And then you will use the encode and decode functionality for encoding your data and decoding data, basically converting the categorical features into numbers. And then you can use the getMapping function to visualize the mapping between the numbers and the categories assigned. So now, before moving on to the OneHotEncoder, so we have to make a little parenthesis to quickly speak about a numeric field dataset. So the numeric field dataset is the data type which is used by most of the machine learning algorithms in the HPCC Systems Machine Learning library, as well as all the remaining modules use a numeric field type dataset. So it has, you can see that on the right, it has 4 fields, WI, which stands for the work unit item, and basically helps make use of the parallelism provided by the HPCC Systems platform. Then you have the ID, which represents the ID field of your data set. And then you have the number, which represents the field ID. So in this case, you represent the ID of feature 1, feature 2, or feature 3, and feature 4. So you have 1, 2, 3, 4. And then you have the values. So you could do this manually, but there's already a built-in function in the ML Core library which allows you to make this conversion easily. And the toField macro, you will pass in the data you want to convert into numeric field, and then the name of the result. And you could also specify what ID in your field is the what field in your data set is the ID field. So now we will move on to the OneHotEncoder module. So this one allows you to handle categorical features with no ordering relationship. So if you don't want any of those features to be considered as higher than the other, for example, if you have a color field, then you will use OneHotEncoding. And it will create a new binary features for each of your categories. And then the 1 will basically mean the value is present, and the 0 will basically mean the value is absent. So this is the API of the current API of the OneHotEncoder. So similar to label encoder, you have a GetKey function, an encode, and a decode function. But you also have a constructor. So actually, you can construct the encoder in 2 different ways. You can either pass in some data in the feature IDs in your data set, or you can just pass in the key if you already have a key you have built before. So this is a quick example of using the OneHotEncoder module. So you have a line 3. The module is being initialized with some basic data, maybe your training data, and then the feature IDs will basically tell him, okay, the second field in my data is the one I want to OneHotEncode. You could pass it many more numbers depending on the number of categorical features you have. And then you will use that encoder to encode or decode your data set at the end. So following the OneHotEncoder module, you have the scalars. So standard scalar, minimal scalar, and normalizer. So if you have this 2 feature data set on top, which is clearly out of scale, you could use the standard scalar if you want each of your features to have a normal distribution. You could also use the minimal scalar if you want your features to be within a specific range. And you could use the normalizer if you want to normalize either using the L1 norm, which is normalized to the sum of the absolute values of each row, or the L2 norm, which is normalized to the square root of the square of the square root of the sum of squares. And then you could also normalize it using the L infinity norm, which normalizes it to the maximum of the maximum absolute value of each of the rows. So those are the three tools currently at hand for scaling your data. And then their APIs. The APIs are shown here. So you have the standard scalar API and minimal scalar API. They both have three similar functions: GetKey, scale, and onScale, which scale for scaling your data, and onScale if you want to do the reverse operation. The GetKey function to have the key used for scaling. So as far as the standard scalar is concerned, the key is actually the means, the averages, and the standard deviations of each of your features. And for the minimal scalar, the key is the minimums and maximums for each of the features. So they're both different just in terms of their constructors. So the standard scalar, you could just pass in some data or a previously built key. Or in case of the minimal scalar, there are some extra parameters. You can specify the lower bound or the upper bound. So by default, these are set to 0 and 1, and you could set it by yourself if you want to change these boundaries. Then the normalize is not a module. That's why it doesn't have the same structure as the others. It's just a function which takes as input the data you want to normalize and the norm, either L1, L2, or L infinity norm. So this is scaling, an example of using the minimal scalar. So line 4, you have the scalar which is initialized with some training data, and then you will use it to scale and unscale your data. So finally, we have the split functions. So currently you could have two ways to split. So you have a simple split where you will tell him at what percentage. In this case, this is half. You want to split your data, or you could use stratified split as well. So stratified split allows you to maintain the proportions of a feature if you want to. For example, in the slide you say you have the label Y, which has 50% 0 and 50% for 1 as well. If you want to maintain that while splitting, you can use the stratified split function. So those two functions API are shown here. So you will pass in the data you want to split, then the training size or the test size, or both if you want to. And then there's also a shuffle parameter if you want the data to be shuffled before splitting. The stratified split function takes an extra parameter, the label ID, to tell him on which field you want to maintain the proportions. Okay. So you have a little example on using the split function. So you pass in the data and then the size, in this case, half, 0.5, and you can get the training data and then the test data. So to sum up, currently we have three main group of modules in our preprocessing bundle. So we have modules for handling categorical features, the label encoder and the OneHotEncoder. We have scaling modules, standard scalar, minimal scalar, and normalize, and then we also have splitting functions, split and stratified split. So the current version of the bundle is available at this link, GitHub repository, and this link is the following link: using HPCC Systems Machine Learning libraries available for any new HPCC Systems user in terms of the machine learning library of the HPCC Systems platform. And then currently the bundle has been thoroughly tested for making sure the output is expected. So currently we are undergoing the performance test to make sure as well it runs efficiently, because it has been, while implementing the bundle, we had in mind to use the data parallelism made available freely by the HPCC Systems platform. So we are currently undergoing the performance test, and then that will be it. And then I will definitely invite you to download the bundle and use it, because the next steps, most of the ameliorations and changes will be based on the feedback from the users, because this is made for the community and to improve the HPCC Systems Machine Learning projects made on the HPCC Systems platform. So I will end by this poll question. So among the modules presented, which one would you use the most? Thank you for listening to me, and I will pass it over to Paul.
All right, Vannel. I mean, that was great, because, I mean, speaking personally with working with machine learning lessons, we have a whole new machine learning course. If all of you out there didn't know, it's out there. And in all of the lessons, all of the bundles that I work with, whether it be DB-Scan or GNN or linear regression or learning trees, all of them have to have the data prepared correctly. And I thought that was the most daunting task for me at first, was not only just we get a data set that you think might be good for machine learning, but then what are the steps involved in getting that data prepared? So well done, Vannel. This is a good addition to the machine learning bundle library. And I want to go through the first question of the poll with everybody, and take a look at the questions while I do that. And then we'll hit some questions, and then we'll go back and look at the second poll question result. So the first poll question was, what do you think is the most time-consuming phase of a machine learning project? And I have to confess, I think you gave it away a little bit, Vannel, because we have 100% of the group said that data preparation was the most time-consuming phase of a machine learning project.
Yeah, expected.
All right.
Expected.
So, are you ready for some questions, sir?
Yes, sir.
All right, number one, how efficient, in your opinion, are the pre-processing algorithms?
Also, I mentioned that the performance testing are done right now, so we mainly focused primarily on making sure that the output is as expected, so you don't want to scale and get some weird numbers. So that took most of the time for now, but currently we are undergoing the performance testing, and we will compare it to what the sklearn library, how much time also the same processing goes with the sklearn library. So that will be the comparison. The numbers will be out, and we are expecting that before the October 5th of the Community Day.
All right, sounds good. You can probably add some notes to like maybe the documentation inside the code as well.
Sure.
Here's the next question. Where do you go from here now? What are your next steps in the pre-processing bundle? You have any ideas of extending it somehow?
So the main extension, I would say, we don't really plan on extending that really early, because it is a lot of modules. So we do expect users to have some feedback or some complaints about the namings, and so before extending anything, we would love to have enough feedback on what has been done right now, and making sure we have a good base to build on. So we don't want to build something very big and have to make a lot of huge changes. Yeah.
Okay. All right. Here's a question I think is interesting. I don't know how I would answer this, but here goes. Do you have any statistics or theories about how much faster it will be for people to use your pre-processing bundle with HPCC Systems Machine Learning? I guess what they're asking there is you know, how do you think it'll be a good addition, I guess, or how important will it be as part of the bundle? I mean, in my opinion, I think it's great. I think it's an extra tool that you can use to clean your data. I like the split functions particularly, and the OneHotEncoder is good, especially when you're working with deep learning. But let you answer this.
I mean, I would say many people are kind of used to sklearn, so the speed sklearn is providing is what at least they will expect. So we'll make our best at least go either faster than them or at least at the same speed. So basically, the sklearn three will be the, I would say what?
All right.
The model. Yeah.
All right. Very good. Let's see. Let's go with that poll question. I'll look at the poll results for that second question. Then we have one more question for you, Vannel, if you don't mind.
Yeah, sure.
All right. So among the modules presented, which one would you use the most? And it looks like most of the people like the label encoder. They really like the label encoder that you demonstrated. All right, and one last question for you. Or it looks like there was another one that popped up too. All right, I think we already answered that one. So I'm going to go ahead and we'll just go with this one more. Do you think your work this year would have made the work you did last year easier?
Definitely, and this is because currently, as I made the module, I also wrote a little tutorial to have a end-to-end machine learning project using this bundle, and I was able to have label encoding done in one file in few lines of code, standard scaling and OneHotEncoder also done in few lines of code. So that definitely reduced the amount of time I made on those steps. So yeah, that would have definitely helped for my previous project. Yeah, because I did have labels initially in my initial data set. I did have letters. I didn't have numbers initially, so I had to write functions to convert that into numbers.
All right, Vannel, thank you.